All right, kiddos, so this is going to be our Unit 1, Day 11 lesson video. We're going to be going over our last rigid transformation, and these are rotations, and we're only going to study rotations about the origin. Okay, so real quick, let's review what the origin is. So if I've got a Cartesian coordinate plane, you got x, y. This point right here where they intersect at the 90-degree angle, otherwise known as the point 0 by 0, right, where x equals 0 and y equals 0. This is called your origin. Okay? So we're going to be looking at rotations about the origin. First of all, we're going to answer what's a rotation in general. Then we're going to answer the directions known as clockwise and counterclockwise. You often hear that associated with either spins or rotations, same idea. Then we're going to talk about rotating figures in increments of 90 degrees, either clockwise or counterclockwise. Then we are going to see some equivalencies between 270-degree rotations in either direction. And we're going to see what the deal is with 360-degree or full circle rotations, right? So first, let's talk about what a rotation is. Let's talk about what a rotation is. So let me draw a crude little Cartesian coordinate plane. So x, y, and let's say we've got a figure here. Let's say we've got a triangle with 3 vertices, which is what we're often going to use transformational experiments. So this triangle has 3 vertices, A, B, C, right? And we want to rotate this triangle about a center of rotation, and that center of rotation that we're going to study, again, is the origin. Okay, the way that this is going to work when we rotate, okay, so when we rotate a figure, and I'll go ahead and use orange to show my little rotation triangle. When we rotate a figure, what needs to happen is that our figure's vertices keep the same distance from the center of rotation. Okay, so this vertex C here, see I drew a right triangle. That vertex C there is going to maintain this same exact distance right here, this same exact distance from our center of rotation. Okay? So this distance here, we'll just call it D for distance. And that distance needs to remain constant. So let's say I rotate it. And I'm going to look at this leg of my right triangle. Let's say I rotate it 90 degrees. We'll go ahead and talk about clockwise and counterclockwise. So see this arrow, how it's turning left? Imagine turning a steering wheel and you want to turn the car to the left. To turn your car to the left, right, you want to turn the steering wheel counterclockwise. Okay? To turn your car to the right, you would spin the steering wheel clockwise. Okay, so right here, counterclockwise. Okay, and right here, clockwise. Anywho, let's say we're going 90 degrees counterclockwise with this triangle in green, ABC, and we're going to get a new triangle. Draw it about the same there. And remember, we want to maintain the same distance D. So this is still D away from our center of rotation here. That is the origin. Okay? So our new triangle, still going to be ABC, and I'll do this one in blue. Our new triangle is going to be over here, right? So there's our new, we'll call that blue C. I'm not going to number them just yet. Okay, so where are the other points going to be? Well, in order to figure that out, we're going to have to do this same process again. Okay, and you can see this is quite tedious. So you're probably wondering, well, what is the math for this? Wouldn't that be a lot easier? And the answer to that question is, well, duh, right? But you have to see where the math comes from. Okay, so now we have a new d for distance, and I'll go ahead and erase my old one here in pink. See if I can, oh no, I didn't want to do that. Do that, I'll just leave that one there. Okay, so we have a new distance here, and we want to do the same thing. We want to go 90 degrees, counterclockwise, because we're turning left, quote unquote, right? So let's see how it looks. Okay, and this is a whole bunch of imagination power. So I'm going to try and draw at the exact same distance there. Okay, and got the same distance in y. Okay, so we see our new distance here in pink, and we can pretty much see where our new B vertex is going to go. Okay, and from that we can go ahead and deduce that our A vertex is going to be out here. Oops, wrong color. That should be blue. What's the matter with me? Okay, so what we get is the rotated figure. Okay, and what I've done is a 90-degree rotation, and the direction I've gone is counterclockwise. Whoops. Okay, and we can see, I mean, if you just look at this, right? If ABC was the, a plane, and A was the nose of the plane, right? It turned 90 degrees counterclockwise, and now it's facing off this way in a direction we could call west. But in a nutshell, this is what rotation of a figure about some center of rotation is. So how do we put that into words where we can go ahead and answer EQ1? What is the rotation of a two-dimensional figure? Okay, so again, we have something that just seems obvious, but it seems very difficult to put this into words. So basically, in the most basic language that I can think of, I would just say that what we're doing is we're turning a figure in a way where vertices, again, maintain their same distances, right? So maintain distances, except they're maintaining distances from a center of rotation. And in our case here, our center of rotation was the origin. Okay, and that's the only type of rotation we're going to study in this class. Is rotations based on the center of rotation being the origin each and every time. Okay, otherwise it gets really gnarly and there's really no need to go that far with it. So we're going to just keep it about the origin. So let's go into depth on rotating clockwise, and then after that we'll go into rotating counterclockwise. First, let's do clockwise. So when we're rotating clockwise, well, let's start with a 90-degree rotation clockwise. And again, clockwise is turning your steering wheel right, or it's the actual direction a clock goes in, right? Whatever's easier for you to relate to. Okay, so when I do this, if I rotate this guy 90 degrees, let's say 90 degrees clockwise, right? So this is going to come over here 3, I'm going to go down 1, okay, and, whoops, I shouldn't have gone down 1. Over here 3 and up 1, what's the matter with me? There we go. So I'm going 90 degrees clockwise. So my new vertex A is here, Okay, and I would follow suit with all my other vertices. So I'm going to go ahead and erase, and then I just do it again. So now I'm going to go with B. And again, like I talked about earlier, this is quite tedious. This is quite tedious. So I'm going to come out 4, right? Because that's how long this is. So I'm going to come out 4 this way. And I'm going to go 3 up. Okay, so there's my B. And I'm going to go ahead and erase. And I'm going to do this again for my vertex C. And again, take note of the fact that I'm maintaining these distances, right? So I'm going to take this guy, go 90 degrees. That puts it right here because it's too long. And it's 3 up this way. So I've got that same distance. And there's my new vertex C. And I have my triangle ABC. Now, what are my new coordinates? So my old coordinates are listed right here. So what are my new ones? Let's see if we can establish some kind of a pattern. Okay, so vertex A went from -1 by 3 to +3 by +1. Okay, B went from -3 by 4 and it became 4 by +3. Oops. Okay, and what about C? C went from -3 by 2 to 2 by +3. So basically, we started out as x comma y, right? That's how we started out here in red. And I'll go ahead and underline in red so you can see. And from there, where do we end up? Well, if you look at your y coordinates, right? All of your y coordinates, they just kind of did the flipperoo there. They all moved over, right? So look at C. Look at C. 2 was the y coordinate for C1 here in red. For C in blue, it became the x coordinate. So we can go ahead and say it's safe to say y changed places with x, right? And what happens to the x's? Went from -3, -3, -1 to +3, +3, +1. Okay, +3, +3, and +1, right? So basically, our change was x and y flipped, x and y flipped, and we had the x sign change. So that would be our algebraic rule, right? Okay, so what if we go a little further? So what if we go, instead of 90 degrees clockwise, what if we try 180 degrees clockwise? Again, we're talking turning the steering wheel to the right or the clock direction, right? So 180. So let's draw our little right triangles again. And again, you can see that this is quite tedious. So I'm going to rotate 180 degrees clockwise, turning the steering wheel right. So now I'm at 3. That puts this guy 1 out here, and I maintain my same distance. There's my new point A, right? Okay, and we can already kind of guesstimate where the other two are going to be, just based on the fact that this triangle just kind of points in the direction it's going. But let's go ahead and continue. So here is A, and we'll call it A2, even though it's in a different color. So now let's see where B is going to end up. Okay, so again, I'm maintaining my same distance, and I'm going to rotate 180 about the origin, right? So I'm going to go I'm going to go down 4, because that's how long that leg of the triangle was. And I'm going to go across 3, and that puts me right here. And there's my B2. Go ahead and erase, and do the same thing with vertex C. Up 2 over 3. So down 2 over 3. It looks like I accidentally erased my B vertex. You guys knew where it was. So there's C2, A2, and B2. Okay, so now let's see if there's a numerical pattern that we see. Let's see if there's a numerical pattern. So let's go ahead and label these out. So A2 is 1 by -3. C2 is 3 by -2. And B2 is 3 by -4. Okay, so what's the pattern? So let's look at A first. So A1 was -1 by 3, and now we have 1 by -3. Let's look at B now. -3 by 4. Now I've got +3 by -4. Okay, so the pattern's starting to emerge. So C, let's look at C1. So -3 by 2, and now I've got +3 by -2. So our algebraic rule seems to be that we're going from x, y normally, right? And we're becoming -x, -y. Okay, and let me draw somewhere else because I didn't give myself enough room. So again, to reiterate, it looks like I'm going from x comma y, right? And then I rotate 180 degrees clockwise. Oops. Clockwise. And I end up with -x, -y. So I've got x and y staying in the same place. There's no flip happening. I just have x, y, sign change. Okay, so that would be my rule there, right? So now, let me ask you this. Do you think it would matter what direction I went? If I went 180 degrees clockwise or 180 degrees counterclockwise? Do you think it matters? The answer is no. Okay? 180 degrees clockwise, and I'll go ahead and write a little note. 180 degrees clockwise is the same. It's the same as 180 degrees counterclockwise, right? So that's an important thing to note, okay? 180 degrees in either direction looks exactly the same. All right, so now let's talk about even further. So let's go 90 degrees further than 180. Okay, so I'm going to take my point A, and instead of going 90 degrees, instead of going 180, I'm going to go 270 degrees, and I'm going to go clockwise. Okay? So I'm going to take A, and same center of rotation, right? So right here would be 90, right here would be 180, and right over here is 270. So I've gone more than half a circle. Okay, I've gone more than half a circle. I've gone 270 degrees clockwise. Okay, so where is everything else going to end up? Well, I'm just going to go one down, right? And that's going to put me right here. So there's A1. And I'll go ahead and erase. Okay, so now let's see where C will end up. Keep that same distance, right? So I'm going to end up let's see, so 2, 2, I'm going to go 2 here, and I should probably erase that one. I don't know. It doesn't seem like my eraser is going to work right now. Okay, got my eraser to work. You still suck really bad, Microsoft. You're still terrible. Anyway, so 2 here, and then 2 over this way, so that's the full 270. And now I'm going to go down 3. And that's going to put my new C vertex here. We'll call that, we'll call that C2. I don't know why I wrote a 1 there. And we can already tell our B2 is going to be here. Okay, so what is our numerical pattern this time? Well, our numerical pattern, so C2, let's look at the C's. We've got -3 by +2. Now I've got -2 by +3. What about B? I went from -3, I went from -3 by 4. Now I'm at -4 by -3. And our new A coordinate, we went from -1 by 3 to -3 by 1. Well, -1. Okay, so we're starting out x comma y, and where are we ending up? So let's look at the x's. So -1, and I'm looking at A right now. So -1, so x and y flipped. So I've got x sitting over here, and what happened to the y this time? The y flipped over here and also became negative, so this should become -y comma x. All right, so I know this can be pretty cumbersome, but actually we've already eliminated a lot of these EQs. So we already understand what is clockwise, counterclockwise. How do we rotate a figure 90 degrees clockwise about the origin? Okay, we've answered that. We've answered number 4 and number 6. We have answered number 3, 90 degrees clockwise about the origin. And we're fixing to answer these last few. Okay, these are very, very inherent. So let's talk about counterclockwise. Okay, so now let's look at counterclockwise. And again, counterclockwise is turning the steering wheel left or going the opposite way of the clock. And we're still rotating about the origin right there, 0 by 0. So let's go ahead and get started. So I'm going to draw my little distance right triangle that I'm going to use. And I'm going to turn it 90 degrees counterclockwise this time. So I'm going to be 2 by 1 right here. And that right there is going to be my A2. Go ahead and erase, and let's see where my other points are going to end up. Okay, so let's look at B now. So that's a 3 by 3. So I'm going to go up 3 over 3. That's going to put me right here. So there is my B2. And now I've just got to move C over. So over 1, down 3. So that's going to be a 1 by 3. So I'm going to go 1 by 3, and that puts C2 right there. Okay, and let me erase some of this mess here so that we can begin to look at the actual numerical pattern. So what was it that happened? So A, I went from 2 by -1 to 1 by +2. Looking at B, what happened there? I went from 3 by -3, and I changed to 3 by +3. And C2, I went from 1 by -3 to 3 by +1. Okay, so that's right there. The pattern that I see here when I'm going 90 degrees counterclockwise is that I'm going from x comma y to -y comma x. Okay, and if we look at the y, so looking at C, right? So the y traded places with the x, and the x stayed the same. The x was positive. Its sign didn't change, so it just did the flipperoo with the y coordinate, but the y's sign did change. So we're just going to say flip and y sign change. Okay, pretty basic rule right there. Now, let's move on to, so this was 90 degrees counterclockwise. Let's look at 90 degrees more, and we've already established that 180 degrees is the same in either direction. So let's go ahead and see if that's true or not. So if I take this same A1 and I rotate 180 degrees this time, so that's 2 by 1, 2 by 1. That's going to put me here for A2. And we can go ahead and see where our two other vertices are going to end up. Okay, so let's see if it works out. Let's see if it works out the same. I'm going to use a different color here. Let's see if it works out the same if I go clockwise this time. So I'm going to take the same vertex A, and I'm going to rotate it 180 degrees clockwise this time. Well, that's still going to put me in the exact same spot. Okay, so again, 180 degree rotations, same either direction. Okay, so we have the same rule. Okay, we're going from x comma y to -x, -y. All we have is an xy sign change. And it doesn't matter which direction we're going in. Okay. One last one. Let's look at 270 degrees. And again, we're doing counterclockwise. Okay, so 2 by 1, starting with the A. And I'm going to end up here. And that's going to be my A2. Okay, I went 90, 180, and then 270 degrees. Okay, now when I rotate this, you're going to notice something a little familiar. So let me go ahead and work on my other vertices. So let's go ahead and rotate C. So I'm going to take this guy, rotate 90, rotate 180, and then rotate 270 down to here. Okay, and that's going to put me right here. Oops, by 3. What's the matter? It's going to put me right out here. That's going to be C2. And we can already tell B is going to end up here. Now, what is our numerical pattern? Before we do that, this ought to look familiar. Let's back up for a second. Let's look at 90 degrees clockwise. 90 degrees clockwise. Okay, so when we go 90 degrees clockwise, it's actually the same thing as 270 degrees counterclockwise. Okay, so just to prove a point, let's try that. So I'm going to start with A. I'm using a different color here. and I'm going to go 90 degrees clockwise this time. So that means I'm going to go from here to here. So that's 2 by 1, and holy dog crap, it's the exact same thing. Okay, so 270 degrees counterclockwise is the exact same thing as 90 degrees clockwise. All right, they're the same thing. Okay, and it turns out 90 degrees counterclockwise is the exact same thing. It's the exact same thing as 270 degrees clockwise. Okay? So, our numerical pattern that arises here when we go 90 degrees clockwise or 270 degrees clockwise, if we just look back over here. So what was 90 degrees clockwise? That was just y negative x. So we went from xy to y negative x, meaning we're just flipping and x sign change. Okay, so this is all really confusing, and trust me, I know. Okay, so this is why I have this summary here at the end. This is going to help you answer all the EQs. Okay, so we have gone ahead and answered all of them. Okay, and the last EQ may not seem that obvious, but I mean, come on now. So if I've got x, y, and I've got a triangle here, A, B, C, right? And I go ahead and I rotate it about the origin 360 degrees. So I'm going to take this leg, this whole triangle, this whole thing, and I'm going to rotate 360 degrees. Well, where am I going to end up? I'm going to end up in the exact same place that I started with the exact same triangle. Okay, so that's where this is coming from. Okay, 360 degrees clockwise or counterclockwise, we're going to get the exact same result that we started with. Okay, we also saw that 90 degrees clockwise was the same as 270 degrees counterclockwise, sorry. These two were the same. That's why I have the or there. And same thing here with 90 degrees counterclockwise. We saw that it was the same as 270 clockwise. Okay? And I know this is super confusing, but just trust me, write this stuff down, follow these rules, and the guided practice will be a cinch, I promise. There's only 2 rotations on, well, okay, 3, but you're going to see on number 7 why I'm not even going to count that one. Anyway, any questions, as always, shoot me an email or ask me during class. That's all I got for this video. Goodbye.